Today's session is entitled Design, Deploy, and Optimize SQL Server on vSphere. In this session, actually let me get this on first. Okay, of course the obvious disclaimer. In this session we're going to talk about, we're going to run the whole gamut. We're going to talk a business overview of SQL Server on VMware. And as we move through the agenda, things will get more and more technical. We'll go through benefits of SQL Server on VMware, SQL Server on VMware performance. That's a 2008 performance study that we've done recently. We'll talk about database consolidation techniques. Traditional database consolidation, where you're consolidating multiple instances or multiple databases on one physical server, versus the VMware method. We'll look at SQL Server guest best practices, a few things that you can do inside the guest to tune SQL. Availability and recovery options. We'll discuss failover clustering, mirroring, log shipping, in conjunction with HA, vMotion, DRS, Site Recovery Manager, and backups. Then, of course, we'll have a few links to some online documentation at the end. So, actually, let me do a quick poll. I'm curious who's in the audience. Who's a manager? All right, we got a few of you. Now, who's an infrastructure admin, a VMware person? Wow. Oh, my goodness. All right. How about application owners? Okay, a few. All right. And DBAs or developers? Okay, great. So when looking at consolidation in respect to databases, there's somewhat of a conflict of interest. And we'll talk about application owners / DBA. The application owners are trying to fulfill the needs of their application. They may say that the application requires a certain patch or service level. They may have custom-written code that requires an earlier version of SQL Server, like 2005 or 2000. They may say that their application, because it's so critical to the environment, needs dedicated resources, and they may resist virtualization because of that. And then also on the development side, they have some issues like, why does it take so long to get infrastructure to provision a SQL Server? Then you move over to the infrastructure admin, who's sort of kind of caught in the middle. We may, on one hand, they agree with the CIO. We waste hardware on underutilized SQL servers. We have to buy one-to-one hardware for the DR facility. And, application owner, we're so busy with production issues that we just don't have time to provision development machines. Then on the far right, the CIO is pushing, we have too many servers. We need to lower our power and cooling costs, and we need to reduce the cost of business continuity. To sort of compound the problem, it's a good thing and a bad thing. The advent of these large multi-core servers is making it difficult for applications to take full advantage of the hardware. So more physical cores per socket, more physical memory, resulting in a smaller data center footprint. The downside is that with bigger and bigger servers and applications that can't take advantage of all the cores, you end up over-provisioning and you end up wasting hardware. That's where we lead to database sprawl and cost. We did a survey of our capacity planner database, which had 700,000 servers in it at the time, physical servers in real-world production environments. And what we found was 9% of x86 servers run SQL. That's a pretty astounding number, especially if you're looking to consolidate your infrastructure. SQL is a great choice because of the number of SQL servers that are out there. But not only that, but they're typically low utilization, average of 6% utilization across 10% of 700,000 servers. And typical utilization range between 5 and 15%. Very few were above that. And we believe this is due to very difficult sizing of SQL Server. SQL Server is highly dependent on the application that runs against it. And many applications have very cut and dry guidelines on how to design SQL. Others don't. And so the ones that don't provide really concrete guidelines, you tend to over-provision just to make sure. So what are some of the benefits of SQL on VMware? Utilize all your server processor cores. Utilize the full extent of these 16-core, 24-core servers. You can consolidate dedicated and isolated environments for all users on just a few physical systems and benefit from server consolidation while still preserving database server isolation. You can also consolidate SQL servers with minimal impact to applications. One of the most difficult aspects of a traditional consolidation approach is application remediation. You go through your list of 450 apps that you have, and maybe 75% of them can move to SQL 2008's R2. But there's always going to be exceptions, and you have to deal with those exceptions, and they can be a real pain to the consolidation project. So we can consolidate SQL servers without changing anything about the SQL server. We take it directly from physical to virtual. It's got the same computer name, it's got the same database, same connections, so on and so forth. So we preserve the OS, application, and security isolation. We can avoid the complexities and logistics of app remediation, and on top of it, without clustering, benefit from VMware load balancing. There is an opportunity, and you have to be careful with this. SQL licensing is more complex than the product itself. But in some cases, you can consolidate SQL Server licenses and get some cost savings. So in this example, what we have is, with SQL Server Enterprise Edition, you have the ability to license, you can license the box essentially by socket, okay? So what we have here is 8 physical servers, each with 2 processors. So that results in 8 servers, 16 processor licenses, a total of $596,000 when you consider Enterprise Edition, the server hardware, and software assurance. If we were to consolidate those 8 SQL servers onto 2 physical ESX hosts, each with 2 processors, you can see the drastic savings in the amount of license costs. And because most SQL servers are 6% utilized, it's very feasible that you would get 8 SQL servers onto 2 ESX hosts. Some operational advantages. We can allow you to rapidly respond to changing workloads. We can rapidly provision SQL servers with virtual machine templates. We can hot add CPU and memory to a running SQL 2008 virtual machine. And you can use VMware vMotion to newer hardware if the current platform becomes strained. Some operational advantages. Using virtual machines, you can enhance testing and troubleshooting using clones. You can use snapshots to provide an extremely useful testing and troubleshooting tool. Cloning essentially allows you to make an exact independent copy of a virtual machine, and then you can take that copy and move it into a test or development environment for troubleshooting or patch testing or whatnot. You can also share that virtual machine with third parties like consultants and other vendors. Higher availability with less complexity. So we can reduce planned downtime due to hardware or BIOS updates with VMware vMotion. So if you need to patch the BIOS on your ESX host, or you need to do any sort of thing that would take that host down, vMotion allows you to move those running VMs to another server. So SQL Server instances can be migrated on the fly without interrupting the end users, and you can move to more powerful hardware without any outages. Then, of course, we got VMware HA and DRS. That helps us reduce unplanned downtime due to hardware failure or resource constraints. So if the ESX host fails and your SQL servers are running on that ESX host, then VMware HA will just simply reboot those SQL servers to another host. Now, Distributed Resource Scheduler is a way to load balance SQL servers across hosts, and it utilizes vMotion to move between the ESX servers. Higher availability with less complexity. It's simply easier to recover a virtual machine than it is a physical server because of virtual machine encapsulation and portability and those sorts of things. You can also utilize tools like Site Recovery Manager in order to facilitate recovery. That's enough of the high-level stuff. So let's get into some of our performance tests. So a lot of the reluctance we have to virtualizing enterprise apps like SQL Server have to do with our past. If you look at ESX2, we had a 30 to 60% overhead on the processor side. Meaning if you were running a SQL Server at 40% utilization, you might be running at 100 on ESX2 once you virtualize. We could only support 1 virtual CPU. We could only support less than 4 gigabytes of memory and less than 10,000 IOPS. It's no wonder that application owners think that we don't have the capability of running their application. That was only about 6 years ago that ESX2 was mainstream. So move over to ESX4. our overheads are 2 to 10%. We can support 8 virtual CPUs, 255 gigabytes of memory, and 350,000 IOPS to the disk. In 4.1, the IOP number has actually changed to 500,000 IOPS. So when your DBA says my SQL Server can't go into a virtual machine because it has high I/O requirements, well, if you have the hardware to support it, we have the software to do so. The truth is that the average SQL database fits easily into a virtual machine. Let's go back to our capacity planner data, 700,000 servers. So in the blue there, that's VMware capabilities, the amount of CPU, the amount of memory, IOPS, and so on. In the orange is the average SQL server. The average SQL database uses 2 CPUs and is only 6% utilized. 95% of SQL servers polled were below 30% utilization. The average SQL Server uses 3.1 gigabytes of memory and is only 60% utilized. And this was staggering to me. The average database produces 20 IOPS, and 95% of them were under 100 IOPS. That's not to say there aren't big SQL servers out there, but the vast majority definitely fit inside a virtual machine. So let's look at some performance tests. How are we able to scale? So in this test, we wanted to compare a physical machine to a virtual machine. And so the physical machine is in green there, the native server, and we normalized the results to the output of one physical server with one processor. So as you can see, at 1 and 2 virtual CPUs, ESX is 92% of native performance. At 1, 2, and 4 CPUs on the 8 physical CPU server, ESX is able to effectively offload certain tasks to idle cores. 4 CPUs is at 88%, and 8 CPUs is at 86% of native performance. And these are not small workloads. We were doing 3,557 transactions per second in the physical machine, a little over 3,000 in the virtual machine. And you can see how the results compared in terms of response time, disk I/O, latencies, network, send and receive. This was based on the SQL Server TPCE benchmark, and you can read about this on our website. There's a white paper that backs this up. Another interesting experiment is, in the real world, you almost never run one SQL Server on one physical ESX host. You typically stack workloads. And so we wanted to see what happens when you deploy multiple virtual machines on the same physical host. So this physical host here has 8 physical cores. Each virtual machine has 2 virtual CPUs. So we put one virtual machine with 2 CPUs, then we went up to 2, then we went up to 4, and on up to 8. In the middle there, when we have 4 virtual machines, each running 2 virtual CPUs, we're completely saturated. We're actually fully committing all the physical processors to virtual machines. But we decided to go further than that. We added 6 and then 8 virtual machines. So when you get up to 8 virtual machines here, you're actually scheduling 16 virtual processors against 8 physical cores. So we're overcommitted by a factor of 2 to 1. What we found is throughput increases linearly as we add up to 8 virtual CPUs and 4 virtual machines. And once overcommitted from 4 to 6 VMs, we saw a performance improvement of 1.5x. And going from 6 to 8, performance increases by 1.4x. So the point is that until we completely saturated the CPU on the host, we were able to squeeze that much more performance out of it. And this gives you an idea of the aggregate throughput, 2,760 transactions per second, running disk I of 23,000 IOPS. And the scheduler was very fair in distributing resources. At this point, when you're overcommitted, the scheduler is having to take slices of CPU and give it to the virtual machine. So each virtual machine essentially gets half of 2 CPUs. But what we're showing here is that the scheduler is extremely fair with distribution of resources to all 8 virtual machines. Some vSphere 4.0 features that we use that helped increase performance. When we enabled hardware-assisted CPU and memory virtualization, we got a 22% improvement in performance. By enabling large pages, we got a 19% improvement. And we used other things like the pair virtualized SCSI driver, async IO, and VMXNet transaction coalescing. So let's look at some database consolidation techniques and contrast that with between physical servers and doing it on vSphere. So there are really two approaches here with physical database consolidation. You have multi-instancing, whereby you have a shared operating system, multiple copies of the SQL engine running, and then one or more databases on top of that. In the shared instance model, you're not only sharing the OS, but you have one instance of SQL Server running with multiple databases. So there are a couple of problems with both of these approaches. Number one, in neither approach is there any OS isolation. So if the OS fails in either of these models, you lose all the databases on that host unless you're clustering. If on the left, in the multi-instancing side, if one particular instance or database decides to run away with resources, in other words, use more than is fair, in order to isolate that, you need to use Windows Resource Manager to control resource allocation. And there's no load balancing across physical nodes unless you're using failover clustering or mirroring or something like that. On the shared instance side, again, no OS isolation. There's no database isolation either, so if you lose the engine for whatever reason, you lose all the databases on top of it. If one database decides to take over all the resources, to govern that, you need to use SQL Resource Governor. And again, no load balancing across physical nodes. So we believe that consolidating with vSphere is a much easier approach. It gets you consolidation results much quicker, and it provides some other benefits. Fast consolidation, you can either use P2V conversion, you can swing LUNs. It's easy to get physical SQL servers over into vSphere. Preserve isolation in the VM from an OS perspective, a database perspective, and a security perspective. Guarantee resources with reservations, priorities, and maximums so that those high-performing SQL servers will get the resources they need. And then load balance across physical nodes out of the box with vMotion and DRS. That doesn't mean that we don't want to scale up sometimes. You know, most customers will do somewhere in between, will fall somewhere in between scale up and scale out. In the scale up approach, you have multiple databases per SQL instance. There are fewer ESX VMs, so that's one advantage. Single point of failure is a disadvantage. Scaling up can produce larger VMs, which can introduce SMP overheads, so larger VMs perform slightly slower than smaller VMs. And in 32-bit environments, you can get OS bottlenecks. On the scale-out approach, that's where you're using a single database per VM. It gives you better instance and workload isolation, easier change management. DRS is more effective with smaller VMs and gives you a faster migration. So most customers fall somewhere in between. You know, they may have a few consolidated databases. They may have others that are a single database per VM. So let's look at some of our guest best practices for SQL. Well, first of all, when you're migrating SQL Server to vSphere, you should analyze your existing environment to find out exactly how your SQL servers are being utilized. It's really difficult to design SQL Server in a virtual machine if you don't know how the original SQL Server was performing to begin with. So it's a good idea to monitor that over time and find out exactly how much processor, memory, and disk that you need. It's also good to size conservatively. You should start out smaller and increase later if necessary. Remember, we can do hot add of CPU and memory. We can also move to a piece of hardware that has more horsepower. So one way to go about this is to perform a virtualization assessment with VMware Capacity Planner. That's a really good tool that will go out and tell you utilization of all your SQL servers. Make sure that you pay attention to disk spindles and not just total space. It's very important with SQL Server. Easy migration with VMware Converter. You can do both hot and cold cloning. Start with RDMs to existing data and transaction logs would be another method of migration. So if you're already running against the SAN, you just swing those LUNs over to the vSphere environment, install SQL Server attached to the database, and you're in a virtual machine. And then use templates and clones for easier change management and quicker provisioning. So some general best practices for the database. Every workload is different, and it completely depends on the application running against SQL Server. So follow Microsoft best practices first of all. Make sure that you work with your application vendor to find out what the requirements are for the application. Evaluate your workloads for any SQL-intensive operations. The first thing that comes to mind is, back in the 2000 days, cursors. And there are other SQL-intensive operations that can really increase utilization. Consider scaling out SQL instances for higher-end deployments. You know, one example, and we talk about this in some of our SharePoint documentation, is deploying multiple databases on the back end to service the application can really reduce the utilization of each instance. Make sure that you defrag your SQL databases on a regular basis. If you don't know where to start, it's good to start with 4 virtual CPUs and 8 gigabytes of RAM for medium to larger scale deployments. Make sure that you design the back end to support the required workload in IOPS. When you're monitoring, monitor the database and log disks and look for disk reads and writes and disk queue links to make sure that the system is healthy. Separate the data, the log, and your temp DB onto separate physical spindles, separate LUNs. And this is for a high-end deployment. Now, not all SQL servers are going to require that, but if you have a high-end SQL server, sometimes it's best to have the data on one set of disks, the logs on another, the temp DB on another set. Use dual fiber channel passive storage. For read-intensive deployments, RAID 5 for the database and RAID 1 for the logs. And then for larger deployments, RAID 10 for the database and RAID 1 for the logs. So this goes back to our earlier point about disk spindles. Where customers get into trouble with SQL and Exchange and any other enterprise app is they don't allocate enough resources in the virtual environment, or they don't allocate as much resource in the virtual environment as they did in the physical. So here we have 3 SQL servers. Each of them have 5 disks. Once we move over to vSphere, how many disks do you think we need? 15. We need exactly the same number of disks in virtual as we used on physical. Virtualization doesn't magically remove any disk I/O requirements that the application has. We need to satisfy those requirements in both the virtual world and the physical world. Also consider how you aggregate your disk I/O. So in this test, this is a fairly old test, but it proves a pretty interesting point. So we took a storage array, and we added 1 ESX host to that array. And we measured 4 different kinds of disk access: sequential read, sequential write, random read, and random write. And if you notice on the chart, you know, sequential read and sequential write were the highest performing, whereas random read and write are a little bit lower performing. That's to be expected. As we added more hosts to the array and the workload increased, what we saw is that sequential read started to lose performance. In fact, it started to approach the performance of random read and write once we had, up in this case, 64 hosts running against that array. So the point is that consider how you're balancing your I/O workloads on your array. If you mix a whole bunch of workloads together, sequential read could suffer. So you may want to separate out LUNs that are read intensive onto separate physical spindles. The actual physical files for SQL Server, when we talk about we recommend that the OS/application, the data, the logs, and temp DB be on separate physical spindles for high-end SQL servers. If you use separate LUNs on a single data store, that does not necessarily provide physical I/O separation. For the data, use RAID 10 or RAID 5 if you're a read-only database. This is very important. Your data files should be of equal size. And the reason why is because SQL Server will tend to fill files with more disk space. So if I have, let's say I have 4 files. 3 of them are 10 gigabytes and 1 of them is 50 gigabytes. SQL Server will hammer that 50 gigabyte file until it has the same free space as the rest. That'll produce hotspots in your storage and will reduce performance. If you make all the files equal in size, SQL will be much more even about distributing that workload. Pre-size your data files. Don't rely on autogrow. Instead, manage the growth of your files manually. Autogrow produces a little bit extra performance hit. For your logs, you use RAID 10 or RAID 1 for redundancy and performance, and pre-size your log files, typically 10% of the database size. TempDB is a very important database to SQL Server. It's essentially the care and feeding database for SQL. All of the internal operations, internal messages, logs, things like that, all of that is put into the TempDB database. It's a configuration database for SQL. So, in order to increase performance, you can move your TempDB files to a dedicated LUN. Use RAID 10 for that LUN. Your number of TempDB files typically should be the number of CPU cores. So I'm using 4 cores, I need 4 TempDB files. And just like the data, pre-allocate your TempDB space to accommodate the expected workload. Set your file growth increment large enough to minimize TempDB expansions. And Microsoft recommends setting the TempDB files file growth increment to 10%. So now let's look at availability and recovery options. We often get asked, which one should I use? Should I cluster? Should I mirror? Should I use VMware HA? How do they compare? How do they contrast? Well, I'll tell you that clustering and the application level features like clustering and mirroring are in no way comparable to VMware HA. They're completely different animals, and you should treat them differently, and you would use them for different reasons. For instance, VMware HA protects you from hardware failure, whereas failover clustering or mirroring protects you from application failure. And you don't have to use one or the other. In some cases, you can combine the two to get the best of both worlds, and that's what we'll talk about here in this section. So at the business level, what exactly are you trying to protect? What are your recovery time and recovery point requirements? What is your service level agreement to the organization? And how will you test and verify the solution? So, in other words, I guess the real point of this slide is don't just cluster to be clustering. Cluster when you need it. It certainly is a great tool, but you don't need to cluster every SQL Server database, considering that you still have HA, DRS, and vMotion to use on the VMware side. So let's look at some local site options. Before I go into this, does anybody not know what vMotion, DRS, and HA are? Perfect. So just in a nutshell, vMotion, online move, reduces plan downtime. DRS is a scheduler that uses vMotion to move things around. And VMware HA is a failure response mechanism. VMware HA does not provide you continuous availability. It simply reboots the VM if the host that it's running on fails. In 4.1, we also have the ability in HA to detect a blue screen. So that we allow some level of OS failure. We can detect some level of OS failure. But if you lose the SQL Server engine, for instance, we don't have any way of knowing about that. VMware Fault Tolerance is a feature that came out with vSphere. And this is a great solution for really small SQL servers. The issue with fault tolerance right now is it's only limited to one virtual CPU. So for your smaller SQL servers, this is a great solution without having to use Microsoft failover clustering. What it does is essentially keeps a running VM in lockstep with a shadow copy running on some other host. And this shadow copy is kept in sync. Every single instruction that executes in the primary copy also executes in the read-only shadow copy. And that read-only shadow copy is actually consuming resources on the host it's running on. But we're both connected to the same shared storage. And if you look at the properties of VM1 and VM2 there, they would have the same server name, the same IP address, everything about them is the same. They're completely identical. What happens is if I lose the host on the left, the shadow copy VM takes over. It now becomes the new primary immediately and without interruption. then not only that, but it spins another clone of itself, so that now I'm continuously protected against failure. The beauty of FT is that it takes one checkbox to configure it. Can we talk afterward? So let's look at a standalone SQL Server VM with HA, DRS, and vMotion. How does that work? Well, some of the advantages. I can use standard Windows and standard SQL Server editions. I don't have to buy Enterprise unless the SQL Server requires it from a resource perspective. It does not require Microsoft clustering, and I get some of the same benefits. I can still use vMotion, DRS, and HA to move things around. Quickly restore service during a host failure. It's very simple to manage, easy to configure. Again, HA and DRS are also just a checkbox. And there's no restriction on any VMware features. The issue is that this really protects you only against hardware failures. It doesn't give you any sort of application level protection. You would have to pair this with something else in order to get that app level protection. So here we have a typical application with two web servers, an app server and a database server. If the ESX host on the right fails, HA essentially just reboots those workloads. That reboot takes anywhere between 30 seconds to a couple of minutes, depending on the size of the workload. So what is SQL database mirroring? SQL database mirroring is a feature that came out in 2005. It's essentially, it's very similar to DAGs in Exchange. So essentially what you have is database level replication over IP. This is not Microsoft clustering. It doesn't use the clustering engine. It uses the SQL database engine. So replication happens over IP, and there is no shared storage. There's no quorum disk like there is with a failover cluster. But it gives you the same advantages as failover clustering. Service availability, failover happens in 2 to 3 seconds. If you want to patch the primary server, bring the secondary server up. It fails over within 2 to 3 seconds. You patch one, then fail back, and patch the other. Gives you the exact same advantages. The downside, and kind of the upside as well, is it requires at least 2 copies of the data. So in failover clustering, I have 1 copy of the data. In mirroring, I have 2 copies. So that can be expensive in some scenarios. But it gives you protection from data corruption, unlike failover clustering. Automatic failover is available for supported applications. So the application has to be new enough to have a primary and a secondary SQL connection string. If it supports that, then the application will support the mirror. If it doesn't, you may have to consider using something like a DNS alias. So the way this works, and this is database mirroring in high safety mode with automatic failover. There are different tiers of database mirroring that you can use. High safety mode with automatic failover means that I have a third role called a witness that watches replication between the primary and secondary SQL servers. What happens here is the witness establishes a full quorum when everybody's happy. But if I lose a box, that witness notices the box is lost, establishes a new witness to partner quorum, and the databases fail over to the second node. If I lose the witness, then it's a partner to partner quorum, and it basically does the same thing. Well, it maintains a running state until the witness returns. So let's look at database mirroring on top of vSphere. The truth is, database mirroring is the absolute best and most flexible availability solution for SQL on vSphere. It allows you to use standard Windows and SQL Server editions. Now, in standard edition, only high safety mode with automatic failover supported. You can't do asynchronous mirroring in standard, but many people don't use asynchronous mirroring anyway. It doesn't require any sort of Microsoft clustering. And that also means that we can use all the VMware features. We can mirror our SQL servers. We can still use vMotion on them. We can still use HA and DRS. You can still use Site Recovery Manager. So this protects you from hardware and software failures and database corruption, gives you storage flexibility. So if you guys have done VMware for a while, you know that failover clusters require fiber channel and raw device maps, and there are a lot of restrictions. With mirroring, you can use fiber channel, iSCSI, or NFS. You can use VMDKs or RDMs. Completely flexible. Your RTO is in a few seconds in high safety mode, 2 to 3 seconds. vMotion, DRS, and HA are fully supported, as I mentioned. Now, in order to get these features, you have to use high safety mode with automatic failover, and the client applications must be aware of the mirror or use a DNS alias. So the way this works on vSphere, I've got a full quorum. I lose the server on the right. A witness to partner quorum is established. The database is failover to the mirror node. VMware HA reboots and reestablishes the full quorum without any intervention by the administrator. So let's contrast that with Microsoft failover clustering. Now this has been a good solution for many years, but it's also been a problematic solution. So let's talk about what some of those issues are. It provides high availability through a shared disk architecture. I have 2 nodes connected to one set of storage, and if I fail over, I'm essentially failing over the nodes, but the storage remains consistent. It suffers from a single point of failure because you only have one copy of the data. But that's good in some ways because one copy of the data means less storage. So if you're in a really tight budget environment, that might be an option for you. Automatic failover for any application or user. Doesn't require that special connection string, doesn't require a DNS alias. It's automatically handled with the clustering service. Suffers from heavy restrictions in storage and VMware configuration. You have to use fiber channel, you have to use RDMs, you can't vMotion, can't use HA or DRS with a cluster. So what happens here is that the active server has a reservation, disk reservation to the disk. When it fails over, that reservation is passed to the passive node. So notice we say VMware HA/admin recovery with failover clustering. That's because it is not supported by Microsoft to use VMware HA with cluster nodes. So the way this solution works, it requires Windows and SQL Enterprise or Data Center, automatic failover services, RPO and RTO near zero, similar to mirroring. But again, HA, DRS, and vMotion are not supported. There's no protection from data corruption or storage failures. The storage must be fiber channel and must use raw device maps. So what happens here? The server on the right fails. We allow HA to reboot the web server. The administrator will have to come in and reboot the SQL server. Now, a word on that. Microsoft doesn't support HA for cluster nodes. HA is simply a reboot. So if you go in and right-click and reboot that virtual machine, HA is doing the exact same thing, only programmatically. So in vSphere 4.1, we support HA for Microsoft cluster nodes. And it's because in 4.1 we released the feature called HA Affinity. HA Affinity allows you to control where that passive node is going to boot whenever there's a failure. And so you can keep those nodes on separate physical boxes using HA Affinity. Because of that ability, VMware supports the combination of HA and clustering. Now, a word on vMotion and DRS. It's not a support restriction, it's a technical one. You cannot vMotion a Microsoft cluster node where there's a shared disk, an active disk reservation. We just simply won't let you do it. So that's not a support restriction. But HA, you can choose whether you want to follow Microsoft support or VMware support. But HA is really no different than an administrator reboot. Some caveats and restrictions. The failover clustering has only been tested on 2 nodes in active-passive configuration. It is not supported on iSCSI or NFS. Mixed environments are not supported. So if you use different brand HBAs in the same host, or if you use different versions of ESX across hosts. DRS and HA must be disabled in the virtual machine properties of any VMs participating in a failover cluster. And Microsoft does not support migration of running virtual machines using vMotion that run cluster software. But we've found, both internal tests and with customer POC tests in production environments, we've shown that vMotion has no effect on the operation of a mirror. So again, mirroring is the absolute most flexible solution there. Some best practices for failover clustering. It's fully supported by Microsoft if the listed caveats are followed. If you disable HA and DRS in the virtual machine properties, you will get support from Microsoft. And don't let anyone tell you otherwise. It's fully supported. The only role in the Microsoft ecosystem that's not supported on vSphere is the unified messaging role for Exchange. Everything else is supported, including clustering. Follow VMware best practices for SQL clustering, and you can find that at this link, the 4.0 guide. Use RDMs, or raw device maps, for database and log volumes. Use eager thick zero disks. So when you create a volume in vSphere, that volume is created in a blank state, and those bits have to be zeroed out before the workload can actually write to them. So we can do that in one of two ways. We can let it happen on the fly, which incurs a performance penalty, or we can zero out the disk beforehand. We can do that in a real easy way. When you create the virtual machine, just check fault tolerance. When you check fault tolerance, it'll automatically eager thick zero any disk attached to that VM, then you just uncheck it later. Otherwise, you're going to the command line, VMKFS tools, I believe. So, and you also don't want to use thin provision disks for high-end SQL servers. You typically want to use the fully allocated disk. So eager thick zero is the way to go. Use a separate vSCSI controller inside the virtual machine properties. You can create multiple vSCSI controllers. You might want to do a separate one for the OS, one for the data disk, one for the log disk. You can have several vSCSI controllers inside a virtual machine. That can help avoid software bottlenecks. Use separate vSwitches for your public and your heartbeat networks. And team your physical NICs on the host for network redundancy. A couple of remote site options for SQL, remote site recovery. So Site Recovery Manager is our tool for doing site failover. And we get asked a lot, why shouldn't I just use the application native tools? Why shouldn't I just use SQL Server log shipping or in the case of Exchange, for instance, why shouldn't I use DAGs? Site Recovery Manager is a way of looking at your data center in a holistic way. So I can fail over every application in this data center to this recovery site using the same process, the same technology, the same mechanisms, and avoid having different mechanisms for each application deployed in that environment. So it's much more manageable and much more scalable. Site Recovery Manager relies on storage replication. So we have a SAN in production, a SAN in DR. It's replicating that storage back and forth. Site Recovery Manager sits on top of that and acts as a workflow engine. It allows you to script the failover of those virtual machines from production to DR. It also allows you to safely test. So if I wanted to test the failover production to DR, I could simply do a Site Recovery Manager test. It'll spin up the VMs on the DR site in a fenced environment so that they can't impact anything in production. You can go in and test, make sure everything's okay, and then just discard the test when you're done. The other thing is it's self-documenting. There are no runbooks to update. You can update Site Recovery Manager in the product, and as you make your updates, of course, you don't have to go back to a Word doc or a spreadsheet to update that. So many customers look at a combination of Site Recovery Manager with SQL Database Mirroring. Use SQL Database Mirroring for insight protection, for service availability. It's a really great solution for that. Then storage replication keeps the disaster recovery facility in sync. Then during a site failure, the admin has full control of the recovery, initiates the workflow, and then SRM automates the recovery process based on the pre-configured workflow parameters. And the entire process can be tested without actually failing over services. One of the beauties of this model is that I'm not consuming any power and cooling. I'm not consuming any resources on this side. There are no running VMs. They're all dormant. Once I lose site A, everything as is replicated to site B. So I'm fully protected by mirroring once I fail over to the disaster recovery site. Let's look at backup and recovery for a second. So there are really a couple of different ways that you can back up a SQL Server VM. You can use a standard in-guest SQL Server aware backup solution. That's where you have an agent running in the guest. and handles the database quiescing using the volume shadow copy service. Data is sent over the IP network or streamed. The downside to using this is that it can affect CPU utilization in the guest OS. This is the traditional backup mechanism for physical servers. So if you don't want to introduce a lot of change all at once, you can continue to back up your SQL servers the same way in the virtual environment as you do in the physical environment. Another solution is to use array-based backups. And that's where your backup vendor software coordinates with VSS and creates a supported backup image of the SQL Server database. So it essentially clones the LUN, makes a snapshot of that LUN, and then that snapshot of database can then later be streamed to tape without impacting the production SQL instance. So in summary, understand what the business expects for availability and recovery. For hardware failure protection, VMware HA gives you a low-cost, simpler alternative to failover clustering. Database mirrors can be combined with HA for faster recovery of database servers. Site Recovery Manager allows non-application specific failover of an entire data center. Consider it a site failover mechanism. Failover clustering is supported on VMware virtual machines if HA and DRS are disabled in the virtual machine properties. And then finally, you can either use agent-based or array-based backups to protect virtual SQL servers. All of the data and more, we cut down some of this presentation because of the time factor, and there's a lot of things going on. So you can find all this data and more on our SQL Server Best Practices Guide, which will be out on our Business Critical Applications website. So you can either ask your VMware rep, your SE, or you can go out to the Business Critical Apps website and download these white papers and so on. So here are some links. This is our Business Critical Apps site. If you just Google it, you can type in VMware Business Critical Apps. We have best practices, reference architectures, case studies on all the Microsoft apps, also Oracle, Java, SAP, and then we have VMT and user communities on the email side and on the Oracle database side. Please fill out your survey for this session on your mobile device. Go to vmworld.com/mobile. Thank you very much, and I'll be up here for questions. Thank you.